At first glance, this trigonometric expression looks like an absolute mess of fractions. But today, we are going to make it completely collapse into a single satisfying number tree. Welcome back to Prime Maths Hub. If you are preparing for exams or just love elegant algebra, stick around because we are also tackling a classic quadratic trap in part B that catches thousands of students off guard. We want to show that sin squared theta over 1 plus cos theta plus sin squared theta over 1 minus cos theta is equal to 2. To prove this, we are going to be taking the left-hand side of the equation. At the end of our proof, our answer will be true. So, proof. I'm going to write the left-hand side. Sin squared theta over 1 plus cos theta plus sin squared theta over 1 minus cos theta. These are two fractions to be added. And whenever we have fractions to be added, we take our LCM. So the LCM of 1 plus cos theta and 1 minus cos theta is 1 plus cos theta in bracket, then another bracket 1 minus cos theta. Now, if we divide this LCM by 1 plus cos theta, we have 1 minus cos theta, which will now be multiplied by sin squared theta. Then plus, if we divide this LCM by this other denominator, which is 1 minus cos theta, we're going to get 1 plus cos theta, then everything times sin squared theta. Okay? The next thing we are going to do is to open the bracket in our denominator, in our numerator. We open the bracket in our numerator. 1 times sin squared theta is sin squared theta minus cos theta times sin squared theta is cos theta sin squared theta plus this other one times sin squared theta. We have sin squared theta plus cos theta times sin squared theta is cos theta sin squared theta. Everything over 1 plus cos theta, then 1 minus cos theta. Now let's look at the numerator closely. We have minus cos theta sin squared theta, and we have plus cos theta sin squared theta. These two will cancel each other out. They cancel each other out, leaving us with sin square theta plus sin squared theta. Let's look closely at our denominator. We have difference of 2 squared. Difference of 2 squared. Note, if we have a squared minus b squared, it gives us a minus b, then a plus b. This is what we call difference of two squares. Now let's look at this one. We have a plus b, a minus b. So this one gives us 1 minus cos squared theta. It gives us 1 minus cos squared theta. Now, there's something else you need to note. There is something else you need to note. Note sin squared theta plus cos squared theta is equal to 1. If I make sin squared theta the subject of my formula, sin squared theta will be 1 minus cos squared theta. So it means my numerator, we have sin squared theta plus sin squared theta. That gives us 2 sin squared theta over. Now, 1 minus cos squared theta is equal to sin squared theta. So we have sin squared theta. So sin squared theta is in our numerator and denominator. So they cancel out. This sin squared theta cancels this sin squared theta, giving us 2. Therefore, the left hand side is equal to the right hand side. Is equal to the right hand side. So since they are equal, the trigonometry equation has been proven.